This is chapter number 3, Motions of the Earth. Motions of the Earth. पृथ्वी की गतियां. So let me tell you through this animation or figure that this is sun. Here is sun. Earth is here, and Earth, Prithvi, is revolving around the sun. Revolving sun is fixed and it is revolving. So that is what we call as revolution. Earth is revolving around the sun. Earth is revolving around the sun. This is the first thing. Second thing is, on the axis, imaginary axis, we have assumed Dhuri. On this Earth is also rotating. Earth is also rotating, and this we call it as rotation of the Earth. Rotation of Earth on its axis, that is the movement we call. And second thing, that is it is revolving around the sun, is called the revolution. Revolution of the sun, of the Earth. So rotation, revolution, two things are there. Now come here. Certain things we need to understand. First is, if you see, Earth is tilted. So we make a line, and this is the line of the orbit of the Earth. You saw the line, the elliptical orbit. So that orbital plane of this dotted line is the orbital plane. And we draw a perpendicular here, that is 90 degree to this orbital plane. Now Earth is not like this. If you see, it's tilted. So if you assume the orbital, or it rotate around this axis, it should be like this. This is an imaginary axis, but it's not like that. Our axis, actual axis is this one. Our actual axis is this one. So in this, as I said, the orbit is different. The orbit in which it revolves around the sun. So we need to have an orbital plane. So this is the orbit. This is orbit. And this blue line, if you see here, this is the orbital plane. This is the orbital plane. Orbit. So now we have made an orbital plane here. Now this line is making 90 degree. And now this line, which is the actual axis of the Earth, that is the tilted one, and it is making an angle of 66.5 degree. 66.5 degree. 66.5. So now 66.5 will not be asked. What will be asked? The angle is something different. It's 23.5. How has it come? Now this whole angle is 90 degree. 66 is the angle between the imaginary axis and the orbital plane. But this 90 minus 66.5 is 23.5. So the degree to which the Earth is tilted is 23.5. I hope you got the idea. Tilted angle is 23.5. So whenever you are being asked that how much Earth is tilted on its axis, that is this one. This is 23.5 degree. This is the question important. Apart from this, when the Earth is revolving, now when this Earth is revolving around the sun, it is also revolving, rotating on its axis. So the sunlight is only at certain part of the globe. So, and wherever this light comes is the daytime, and on the back side there will be night time. That means if you take the Earth and you have sunlight here, sun is here, so all the Earth at the same time don't get light. Only one part which is facing the sun is getting the light. The opposite side, which is not facing the sun, is having night time, no sunlight. Now this is 3D picture. This is not 2D. So let me make a circle here. Now this line is actually a circle because it's 3D. So what is this line called? This line is actually dividing, or circle is dividing the part which is having day and the part which is having night. So we can give a name for this line or a circle, and the name is the circle of illumination. This is called circle of illumination. That is, this circle or this line which you see is dividing the part of day and night on two part of the earth, one which is facing the sunlight, one which is not facing the sunlight. And earth is tilted. So if you see that the one part or some part of north pole, some part of the north hemisphere is getting light. This is some extra part, like a slice of pizza. In a normal case, what would happen? This whole part will have day, this whole part will have night. But since this extra part, because it is tilted, earth is tilted, so the light, some extra part is getting, and the down part which should get some light is not getting the light. It's not getting light. Because of this, seasons will come. And some days we are going to talk about specific days which are generally asked. The days are big, the nights are smaller than this. So the globe or the earth is taking 24 hours to rotate on its axis. That is what we call as one day. We can divide it into two parts, 12-hour day, 12-hour night. But this distinction is not very clear, because in between, if you see this night and day, in between there is something called evening also, and something called as dawn also. That is, in the morning time, the day and night are meeting. Evening time also, day and night are meeting, and that is the time. And that is not very sharp. It takes some time to get night or get that day. Now what would happen? There is a question. What would happen if the earth is not rotating? What will happen? It is just fixed, and it is on the fixed way. It is revolving around the sun. What will happen? Thus the sunlight will be only received, or the one only part is facing the sunlight. So the back part will always be having night. It will always be in dark. Even see, if you see plant, they need light to make their food, photosynthesis. So this part will not be able to make their food. And here everything is day. There will be some physical, chemical, all these factors that will make extreme condition and impossible for us to live here on the globe, on the earth. So the day and night, because of this rotation, as I'm saying that this earth, it is going and coming again. So it is taking 365 days. How much does it take? 365 days. And this is called 1 year. 365 days is 1 year. 365 days. After 365 days, we celebrate New Year. But it is not 365 days. It is taking 365 days and 6 hours to be precise. But we only know 365 days. In 1 year, it's 365 days, but it is not. So how to do this? What to do with this extra 6 hours? We have a concept of leap year. What is a leap year? A year in which February will have 29 days rather than having 28 days. It will have 1 day extra. From where this concept has come? In every year, 6 hours is extra with us. So here, second year, what will happen? 365, again 6 hours will be there. So now we have 12 extra hour. Now again 6 hour, third year. So we have 18 extra hours. Fourth year we have 365, and now 24 hours extra with us. Now this 24 hours is 1 day. So the fourth year will not have 365 days, it will have 366 days, and we add it here, 366 days. Every 4 year, the days in the year is not 365, 366, and we add this one day to February. To 2020, which has just gone, is having how many days? 366. 2024 will be the next leap year, and these years, if you can see what has gone and what is still coming. Now every year we can divide into 4 seasons, and the seasons are this sun. See, sun is not here because Kepler law is saying that the sun and the planet, all the planets, they follow an elliptical orbit with sun at one of the focus. It's elliptical orbit. It's elliptical orbit. So it will be at some focal point or focus. So this is the concept here. It is not in the center, like we don't have a proper circle. So because of this only, we get different seasons. And this is also corresponded with this tilt of Earth. So we have summer, winter, spring and autumn. Summer, winter, spring and autumn. And these 4, Garmi, Sardi and this Vasant, these are different. Autumn, these are 4 different seasons. So how do we get these seasons? Here is sun. It is giving different intensity of energy because of the tilt of the earth. Now just watch carefully. See here. Now earth is tilted, so you get more northern part to get more sunlight. Okay. So the northern part is more because it is tilted. So here you get summer. Here in the northern hemisphere you get summer. So whatever I am saying in northern hemisphere, just reverse it to the southern hemisphere. That is, if it is summer in the northern hemisphere, it will be winter in the other hemisphere. Okay, summer northern, winter southern. So this is how tilt and the action of sun corresponds to summer. One day will come here, it is summer solstice. We'll talk about that. 21 June. Just remember this in your mind. Now come here on the second side. Now if you see here, this portion, the lower portion, that is the southern hemisphere, is more exposed to the sunlight. Now the upper portion is less exposed to the sunlight. So now there will be summer in the southern hemisphere. Summer in the southern hemisphere, because more part of the southern hemisphere is exposed to sunlight, and the northern part will at the same time will have winter, and the southern part will have summer. Just in Australia, the Christmas is celebrated in the Garmi, that is summertime. Now this 22 December is winter solstice. Now there are 2 or more positions. One is spring, one is autumn. One is spring, one is autumn. So when northern hemisphere is having spring, the lower part will have autumn. Same is with the lower one. And this is called as equinox. So there are 2 dates, 21 March and 23 September. There will be no difference of day and night time here. So this is how it is happening, because earth is moving around sun, and since it is tilted also, so and it is 365 days, not just it's not moving that fast. It's taking very less time. So 3 months, if you take 3 months on all the sides, it will add up to the 12 months. So you'll have some places getting winter, some place getting summer, some place getting autumn, and some place getting spring. Let me tell you again, whatever is happening in the northern hemisphere, the exact opposite will be happening in the lower part, that is the southern hemisphere. Now there are certain dates. We just discussed about those dates. 21st June. The first date is 21 June. 21 June, and this happens in summer solstice. 21st June, summer solstice. What will happen? What is happening here is, in the northern hemisphere is tilted towards the sun. So the rays which are coming from the sun, they are directly on the Tropic of Cancer Kark Rekha. Because of this, these areas are getting more heat, and the areas which are closer to the poles, they receive less heat, as the rays of the sun are not straight, they are slanting at some angle. Now North Pole is inclined towards the sun, and the places which are beyond or above the Arctic Circle, they get continuous daylight for about 6 months, experience daylight for 6 months. And since a large portion of the northern hemisphere is getting a lot of light from the sun, it is the summer in the region north of the equator. North of the equator. Okay. So the longest day and the shortest night at these places occurs at what date? It occurs at 21st June. 21st June. At this time, and you go on the southern hemisphere. Here, the reverse will happen. Day will be smaller and the nights are longer. And this situation is called as, the position is called as summer solstice. Summer solstice. Coming to the 22nd December, let us talk about 22nd December. And 22 December, the Tropic of Capricorn, Makar Rekha. Now it has come here, if you see here. Now this Tropic of Capricorn, here we get direct rays of the sun. As the South Pole now is more tilted towards the sun. So sun rays, we get a lot of sun rays in the below part. And this fall vertically on the Tropic of Capricorn, straight 23.5 south. And very bigger portion of the southern hemisphere is getting light. And this is therefore summer in the southern hemisphere with longer days and shorter nights are there. And this reverse happens in the northern hemisphere. And this is what we call as winter solstice. We call as winter solstice. Now coming to the 21st March. Here we get 23 September and 21st March we talk together. This is actually the equinox position. So direct rays of sun fall on the equator. Here also. And at this position, neither of the poles, they are tilted towards the sun. So the whole of the earth, complete globe, experiences equal days and equal nights. Because of this equal EQ, day and night time are equal. That is why we have equal, so we call it as equinox. Okay. Similarly, the case is with the 23 September, autumn season. In the autumn season, in the northern hemisphere, and the spring season in the southern hemisphere, which is the opposite case what we discussed for 21st March, when it is spring in the northern hemisphere and autumn in the southern hemisphere. So what you find is the day and nights changes, the seasons, and the season changing is because of the rotation as well as the revolution. So because of the movement of the earth, the motion of the earth, these seasons and etc. are changing. These are the phenomena taking place because of all the motions of the earth. So this is all about this chapter. Thank you so much. Take care of yourself.